Welcome to the Masterclass. You're here because you want to absolutely master the 2026 operational standards in the HVAC industry, and we are going to get you there. Whether you're an aspiring technician building your foundation, a seasoned pro upgrading your skill set, or an operations manager trying to optimize your entire fleet, you are in the right place. We're packing high-density, real-world value into this session with zero fluff. We're talking practical frameworks, massive regulatory shifts, and the advanced methodologies that separate the truly elite operators from everyone else. Let's dive in.
I want you to lock this core philosophy into your mind right now. Verify facts through measurements before making conclusions. This single principle is the absolute cornerstone of expert HVAC operation. It's literally what separates world-class professionals from the average technicians who make that critical, incredibly costly mistake of just swapping out parts without proper testing. In this masterclass, we don't guess, we measure. Everything we cover today builds on this exact evidence-based mindset.
Our curriculum today follows a really clear progressive arc. We'll start with HVAC system fundamentals, move into the highly critical 2026 AIM Act regulations, break down advanced tech like VRF and BAS, explore AI-driven operational intelligence, and finally, wrap up with expert diagnostic frameworks you can use in the field tomorrow. Module 1. HVAC System Fundamentals, covering core components and thermodynamics. Let's start right at the foundation.
To truly diagnose a system, you have to master how these core components interact to manipulate BTU heat energy. Think of the compressor as the heart of the system. It's actively pumping refrigerant through the entire cycle. The evaporator coil is acting like a sponge, precisely absorbing heat from the indoor air. Then, the condenser coil takes over to release that absorbed heat to the outside environment. Finally, your ductwork distributes that perfectly conditioned air throughout the space. It's a continuous cycle, and if even one of these components drops the ball, the entire thermodynamic process collapses. And you know where a lot of technicians completely miss the mark? Right here. Airflow deficiencies, which we measure in cubic feet per minute, or CFM, are very often the actual root cause behind weak airflow or uneven temperatures. We're talking dirty filters, blocked ducts, or closed registers causing massive systemic imbalances way before a mechanical part actually breaks. An elite professional, they always verify CFM and airflow first, simply because so many major HVAC problems actually start entirely outside the mechanical equipment itself. Moving on to Module 2, 2026 AIM Act regulations and the compliance mandate. This is where the landscape completely changes.
You absolutely must understand the sheer velocity of this regulatory timeline because it's coming at us fast. The AIM Act, signed back in December 2020, mandated an 85% reduction in HFCs by 2036. But here's the immediate operational impact. As of January 2025, there's a strict ban on R410A for new equipment. To adapt, the whole industry is shifting to mildly flammable A2L refrigerants like R454B and R32. Because of this, the EPA 608 exam was completely updated for 2024. Your tools, your equipment, your day-to-day field protocols, they all have to be upgraded right now so you can safely handle these new compounds.
And compliance isn't just about new installs. It heavily impacts maintenance too. 10%. That number is absolutely crucial. It represents the strict new annual leak detection threshold for comfort cooling systems, a sharp drop from the previous 15%. What does this mean for you? It demands total, absolute precision in your EPA 608 reporting, your handling, and your management practices. Moving forward, there is literally zero margin for error in your documentation.
Module 3, Advanced Tech, specifically VRF and BAS. We're stepping beyond residential compliance and looking at next-generation commercial systems. Let's contrast traditional architecture with what's happening now. Traditional heat pumps are honestly a bit brute force. They reject heat entirely and operate in a single mode. So the whole building is either heating or it's cooling. But a three-pipe VRF, or variable refrigerant flow system, it operates with surgical efficiency. By utilizing a dedicated liquid line, a hot gas line, and a suction line, along with inverter drives, it can provide simultaneous heating and cooling to different zones in the exact same building. Instead of just dumping wasted heat outside, it recovers it and redirects it precisely to where it's needed. It's a massive leap forward. And building automation systems, or BAS, take this incredible efficiency to the macro level. A modern BAS isn't just a glorified thermostat on a static timer. It actively modulates your HVAC output based on real-time data from environmental sensors. It constantly adjusts capacity based on live occupancy levels and outdoor temperatures, making sure you aren't wasting a single kilowatt of energy. Beyond that, it optimizes your lighting and even integrates directly with life safety and fire protection protocols. This right here is the absolute gold standard of facility management.
Module 4. AI-driven operational intelligence and predictive management. Let's look at how operations are being managed from the top down.
The contrast between traditional software and AI-driven architecture is night and day. Think of traditional HVAC software as a static, digital filing cabinet. It just sits there storing customer data, requires tedious manual scheduling, and leaves you stuck dealing with reactive emergency service calls. AI-driven systems, on the other hand, actively analyze operational metrics to actually predict equipment failures before they happen. They automate and optimize technician routing and generate real-time insights that save time and money. If you want to run an elite organization in 2026, AI isn't just a neat feature anymore, it's the central nervous system of your entire operation.
Finally, Module 5, Expert Diagnostic Frameworks. This is the practical, evidence-based troubleshooting you need to master for field execution.
Like we said at the start, elite technicians do not guess. They use precise tools to extract hard data. Your digital multimeter and clamp meter, those are non-negotiable for reading electrical currents. Your refrigerant gauge set gives you a direct look into the thermodynamic cycle. A manometer and flow hood are mandatory for verifying those CFM airflow deficiencies we talked about earlier. And pulling out an infrared camera instantly elevates your thermal diagnostic game. You use these specific tools because, in a true professional's workflow, hard evidence always drives the diagnosis.
Which brings us to the ultimate professional framework. You need to execute this 4-step process on literally every single call. Step 1, gather your data first. No random guessing. Step 2, verify the true root cause. Remember, the broken part is usually just a symptom of a much larger issue. Step 3, execute a clean, systematic repair. And step 4, which is absolutely crucial, verify resolution after the repair. You have to measure the system's performance post-repair to prove you actually fixed the problem. Skipping any of these steps is exactly how you get recurring failures and destroy your professional credibility.
So, as we wrap up this masterclass, I want to leave you with this question. How will you apply this structured, evidence-based process to eliminate recurring failures on your very next call? Combining these frameworks with a rock-solid understanding of 2026 AIM Act compliance, A2L refrigerants, and advanced tech is exactly what pushes you into the top tier of this industry. Take these strategies, trust the data, and go deliver absolute elite performance in the field.